So, good afternoon, everybody. We start today on the chapter about age and sex composition. So that's chapter 10 of our textbook. And just to remind you, today we will have quiz number 2. So it's going to be open from 4:30 p.m., which is the time that the class finishes here, until noon tomorrow. And you have the results by 1 p.m. tomorrow. Just remember that the quizzes can be any question about any topic that I talked about up to the day of the class. So it can be also about chapter 1. So it can be about chapter 1 and chapter 10, okay? So quizzes, they can accumulate throughout the semester. Even in the last quiz number 20, there is a possibility that you could get a question about chapter 1. But exams, they are specific for those materials that are listed in the syllabus. But the syllabus also mentioned that quizzes, they can go back all the way to the beginning. Okay, so but it's only 2 questions. The majority of people got at least 1 question right. And a lot of people, I think like 11 people, did not take the quiz. I just recommend you not missing quizzes, because little by little these points add up and will help you towards your final grade, because it's pretty much 20% of your grade is based on quizzes. So today we're going to talk about age and sex composition. And this is the outline for the class today. Give a brief introduction about the subject, and then explain a little bit about the concepts of age and sex, and showing how they are important for demography. And then give you an overview of theoretical issues that have been thought about age and sex composition, how they relate to other subtopics in demographic studies. And then talk about population pyramid. Population pyramid is something that you learned back in high school. And nowadays, we don't use the term population pyramid as much anymore, because the populations don't have necessarily a pyramid shape in terms of age and sex structure. So that's why we use the term age and sex structure of the population. Then I'm going to talk about age dependency, and using information about the total dependency ratio, youth dependency ratio, and old age dependency ratio. Age heaping is an issue with the data that we are analyzing. In some countries, people might have preferences to report a specific age that they have, which is not the correct one. So I'm going to talk to you about a method that tries to correct that information about age heaping, like these spikes in ages that you might have in specific countries. And then talk about sex structure, pretty much the overall sex ratio of a population, and then sex ratio at birth, and then the process of population aging that has been happening almost all over the world, but mainly in developed countries. So age and sex are the most important and relevant characteristics of populations for demographers. And because they tell us about the structure of the population. If for overall population, you have the counts of people by sex and age, you can draw the population structure of that population. So exactly because they are so central to demography, age and sex are usually known as the demographic characteristics. Whenever you hear someone asking, oh, what is the demographics of that population? Usually they are referring to the age and sex composition of that population, but they might mean some more things. They might mean what's the race ethnicity composition? What's the merit status composition? was the educational composition. So different people might mean different variables when they mention that, but technically, whenever you're talking about the demographic characteristics, the main ones are age and sex composition of a specific population. And age and sex, the way that people are distributed by age groups and by men and women, by the two sexes, they are tied with the three demographic processes. So fertility, mortality, and migration, they affect the composition of the population in terms of age and sex. These components produce the population's age and sex structure, which in turn influences the demographic processes. And this is important to understand. So if a specific population, we see a decline in fertility in that population. So we're gonna have proportionally less children in that population. By having less children, your population structure will get older. You have more people in labor ages and more people in older ages. And if you see an increase in mortality in affecting more people in older ages, such as here in the US or in the world right now with the pandemic being more deadly among older people, that will decrease the proportion of people in older ages, and then the population will get slightly younger. Or, on the other hand, you might have some still developing countries, if they have an issue, an increase in infant mortality, and a lot of babies die before reaching the age of 1, then you also will have lower proportions of infants in that population that will affect the age structure. And migration usually happens, like the highest migration rates are for people in between, it varies from country to country, but between 20 and 35. So if a specific country receives a lot of immigrants, those countries will have a higher proportion of people in labor ages, 25 to 35. Those countries that send more migrants, they are more immigrant countries, they will lose more people between 25 and 35. So they will have a lower proportion of people in labor ages, right? So this is pretty much the demographic components producing changes in population age structure. And it can also produce changes in population sex structure if any of those here vary by sex. For example, some specific countries like China and India, where you have preference for baby boys, and you might see abortion being used exactly for sex selection of the babies, then you might see that exactly that fertility with a preference for boys will affect the sex structure. You have more younger boys than younger girls. If a specific mortality rate affects more men than women, if you increase violence, and exactly men are the more affected by those specific mortality rates, that will affect sex structure as well. In that case, in more older ages. So what is important is that all these components affect population age structure, and the other way around also happens. Because if a specific country loses a lot of people as immigrants, they all move away, like a great proportion of people move out of a specific country between the ages of 25 and 35, those people are in reproductive ages. So technically, by them leaving, you're gonna have a lower proportion of people in reproductive ages, and then that will affect fertility as well. So it was migration, affect age, sex structure, and then age, sex structure affecting fertility. So for each one of these changes, of these influences in a specific country, in a specific time, we can have all sorts of studies, of demographic studies being done, right? Because whenever you have these variations in fertility rates, mortality rates, migration, you will see changes in demographic structure, and then you might want to do some studies related to that to understand the reasons of those changes. So what exactly are the form? Whenever we are in social sciences, it's really important for us, social sciences in general, and demography as well. It's important for us to know exactly the concepts that we are talking about. We are starting here with concepts of age and sex. In fertility, we're gonna see a lot of specific concepts. In mortality, the same thing. In migration, the same thing. So age is an ascribed and changeable characteristic of individuals in a specific population. In population censuses, it is usually defined in terms of the age of a person at his or her last birthday. In the United Nations definition, it pretty much age is the estimated or calculated interval of time between the date of birth and the date of the census, expressed in complete solar years. So you have to be really specific about each one of these concepts in order to actually collect the data and estimate age structure or age sex structure in a way that can be compared between countries across time. Sex is an ascribed characteristic. So sex, it's also a changeable characteristic, but usually it's with a less change than age. But exactly these two concepts are really important for us to understand how a specific population is distributed in terms of age and sex. So we are trying to do analysis of composition of the population, age and sex composition of the population. We have to get exactly these sets of information. And we think this debate is just good for us to discuss a little bit the difference between sex and gender. And sex, for the most part, though not always, is an ascribed variable whose designation is based more on biology. And there is a really detailed discussion in the textbook about the variable sex and how it can change within a person's life. But usually it's an ascribed variable more based on biology. Whenever we are talking about, oh, I'm gonna do some analysis of gender relations in a specific population. I'm gonna pursue some gender studies. In this case, I'm more discussing non-biological differences between males and females. For example, differences between males and females in migration, marriage, divorce, and labor force participation. Internal migration rates, usually people moving, for example, from rural to urban areas. In more recent decades, the rates of women are higher than for men. Usually, women, on average, marry earlier than men. Usually, women have lower labor force participation than men. And usually, women have lower average earnings than men, even controlling for a series of other characteristics, even comparing men and women as a group that have similar education levels, similar household characteristics in terms of their parents, similar age, similar experience in the labor market, similar occupation. Even with all that, comparing groups of men and women that are similar in all these different characteristics, you will still see, on average, women receiving 30% less earnings than men in a specific population. Overall, that's usually the sex, the income gap due to sex. In that case, I'm using sex, which is a variable available in the census or available in a specific survey, to do analysis of income differences by gender. And I'm being careful to compare subgroups of people that are similar across other variables, such as education, race, ethnicity, age, occupation, and experience in the labor market, for example. But usually demographers tend to use the term sex even when they are discussing non-biological differences, even when they are talking about these power relations, social norms, social rules, social relations that create differences in all these variables here by sex. Usually demographers refer to it as sex, although this is actually an analysis of differences of men and women due to social interactions, due to society inequalities, and that's more related to gender studies, okay? But it's just interesting to know this difference, and you see specific people in specific disciplines using more the term gender than sex. I usually, when I talk about the variable that I'm collecting in the census or in a specific survey, such as the American Community Survey, the Current Population Survey, I'm talking about the variable sex in order to see differences between men and women on a series of variables. So I'm a little bit trying to understand gender gender differences in a specific society in a specific time. Cool? One important thing that we're going to see is that fertility, mortality, and migration, they vary by sex and age. And that's related to that previous slide that I said, that variations in fertility, mortality, and migration causes effects or changes in age and sex composition of a specific population. Exactly because the levels of fertility are not similar across all age groups. We don't have exactly the same number of baby boys being born as baby girls. Fertility varies by sex. And also trying to be a little bit more specific. Fertility means the actual production of children, the number of children that women have. We can talk about, for example, children ever born, which is also called parity. Children ever born is the number of overall children that woman had throughout her life. Or I could ask, in a specific survey, I could ask the woman, did you have a child in the previous year? Just to know the recent patterns of having or not a child. But whenever you're talking about the actual production of children, we are talking about fertility. And overall, there are more males are born than females. The normal sex ratio at birth is usually around, for every 100 girls being born, we have 105 boys being born, on average, usually. That's the kind of like the biological number, the normal sex ratio at birth. But we're gonna see for some countries, some Asian countries, for example, that the sex ratio at birth reached the levels of 120 boys on average being born for every 100 girls. And you remember from the previous class, how do you calculate sex ratio? You get the number of men divided by the number of women multiplied by 100. The sex ratio at birth, you get the number of baby boys that were born in a specific year and divide by the number of baby girls that were born in a specific year in that same population and multiply by 100. So sex ratio, which is one of the graphs that we saw in the previous class, whenever we're talking about sex ratios, the overall number of men and divided by the overall number of women. The sex ratio at birth, I'm just taking those that were born in a specific year. The term fecundity is the ability to produce children. So it's more related to genetics, to biology. women, usually they have children in higher rates around the ages of 15 to 49. Exactly because of that, whenever you're trying to estimate the total fertility rate gives us the average number of children that women in a specific society would have if they were exposed to those rates by age throughout their lives. If I want to estimate the total fertility rate, usually the standard in demography is to consider number of children born only to women between 15 and 49 years of age. Oh, but I know cases of women who had children below the age of 15 or older than 49. But the thing, this is a standard, and a lot of historical data was calculated within this range, this age range. And if you're going to compare to previous years or between countries, usually that's how you get this information. So it's fertility being calculated based on fecundity characteristics of women. But if I mentioned to you also, if you want to understand teenage pregnancy or teenage births in a specific country, let's say that the rates of girls between 10 and 14 years of age of having children increase in a specific country. So in that specific country, you might want to understand those rates and then you estimate fertility for those groups, okay? Could you explain why those outliers are left out? Is it because they are outliers and do not represent the standard? So the idea is, yes, they are outliers because usually women, the rates of having children is much lower below the age of 15 and above the age of 49. And overall, and I'm going to show you some of these rates here. Overall, when we estimate total fertility rates, we are trying to compare them with information that we already know about a specific country. Or if we are doing comparisons across countries, and we are collecting information, for example, from the United Nations Population Division website, or collecting from a specific statistical agency of a specific country, usually they are calculated within these intervals here. It's the same convention that we saw for sex ratio. Sex ratio is the number of men divided by the number of women. Fertility rates are usually calculated for women between 15 and 49. I will show you some examples in class that we can also calculate fertility rates for shorter age groups, for 15 to 19, 20 to 24, 25 to 29, until 45 to 49. With this 5-year age group fertility rates, we can calculate the total fertility rate. But I will show you some examples in which I have data and I estimate the rates also for women between 10 and 14 years of age. I can calculate for that group if that group is important for me, but if I want to compare to historical data into other countries, I just fall into these standards, these ranges here, because then I can make some comparison. Is that clear, Amanda?
Yes, sir. Thank you.
Thanks. And for males, the ability to produce children, it's a wider age interval. So it goes from 15 to 79 years of age. And exactly because the fecundity of men varies so much, this is one of the factors that whenever we are doing estimates of fertility, we usually just ask women about how many children they had. The information about number of children in demographic surveys and censuses are usually asked only to women. And also because in specific societies, women actually have more control of knowing how many children they had, and men don't. So all because of the specificities of specific societies like men having multiple spouses, multiple wives, and then it's not as reliable to collect information from men. And that's another standard. The standard is not just the age range, but it's collecting information about number of children, asking that question only to women. So this is a typical curve of fertility rates by age groups. So they are called age-specific fertility rates. And this is data for the US based on projections from the United Nations. The black curve is for data from 2015 to 2020. We see here these black curves. And then the gray curve is the projection based on historical trends, what we expect the age-specific fertility rates by these 5-year age groups to be up there in 2095 and 2100. The idea here is that the rates, the chances of having children as we move along are being postponed to older ages. So in older ages, women will have higher chances to have children here in the US than they have right now. Older ages, I mentioned here, women from 30 to 34, still young women. But even younger women, 15 to 19, 20 to 24, they will have lower chances. They are expected or projected to have lower chances of having children. And these are rates. Remember, these are rates. I'm getting the number of children that women between these ages had in this time interval, and I divide by the overall number of women within these ages that live in the US within this time interval. And this rate would be a really small number. The number of women who have 15 to 19 years of age who had a child in these years, divided by the overall number of women between these ages in these years. Because this number would get so small, we usually multiply the age-specific fertility rates by 1,000. So what does this number here mean? For every 1,000 women between the ages of 15 to 19 in the years of 2015 and 2020, 20 of them had a child. So 20 out of 1,000. Here's around 70 out of 1,000 for a woman in this age group, right? So it's just important to know what's the unit that you have, that you are analyzing. And what you see here, that the rates, fertility rates for young women and for old women are much lower than for women between the ages of 25 and 34. Yes?
So if you had 2 kids during the age group, would it affect it at all? Or is it just for like 1 kid?
No, this data here, it's the same woman could have reported having more than 1 child.
Okay.
And since this is being grouped by 5 years, the same woman can appear in 2 groups here. Because if the woman was 19 years old in 2015 and she said, oh yeah, I had a child. And then when she's 20 years old, oh, I did not have a child. But then 21, I had another child. So she will count in the numerator and denominator of both of these groups. But usually, the other examples that I'm going to show in class, these fertility rates are usually estimated only for 1 year, one specific year, only for 2015, 2016, 17. Sorry, I didn't repeat the question that I had in the class. The student just asked if the same woman could count more than once. And I said, yes, she could appear more than once here, and she could appear actually in 2 different groups because this is grouped here. But usually, fertility rates are estimated for 1 single year. And when we have that, then of course, she would appear once, right? But this is data from the United Nations. When they do these projections, exactly because these projections vary so much, they tend to group in 5 years, right? So that's the reason that's grouped here. And mortality varies by sex. Females have lower death rates than males at every age of life. This differential has been observed through the centuries and may be attributed to both behavior and genetic causes. Women are stronger, genetic speaking, and in terms of behavior of not engaging in violent activities and so on, that makes their mortality rates being lower than those of men. Males are more prone than females to engage in health or life risk-taking behaviors, such as cigarette smoking. So the risk-taking behaviors, I'm not just talking about violence, I'm also talking about cigarette smoking here or diets and so on. Estrogen, the female's primary hormone, protects the heart and blood vessels, so it's more related to genetic causes. And testosterone in contrast tends to promote higher blood pressure, suppress the effectiveness of the immune system, and increase thrombosis. So all these issues related to genetic causes increases the chance of men dying at higher risks than women. And mortality also varies by age. Death rates are high in the first year of life, so infant mortality rates are high. And as children, they reach age 1, then the mortality rates drop a lot. In modern populations, death rates do not reach the level of the first year of life for another 50, 60 years. And I'm going to explain this more in the next graph. The cause-specific mortality is often age-related. So diseases related to heart conditions, cancer, usually older people are more likely to die because of those issues, right? And usually communication diseases, infectious diseases, children and older people are also more likely to die. So death rates do not reach the level of the first year of life for another 50 to 60 years. This is what I'm talking here. These are mortality rates by age groups. Again, age-specific mortality rates, 2011 for Japan, Guatemala, Nigeria. So here Nigeria have higher rates, Guatemala in between, and then Japan in the bottom. And look at this. For age-specific mortality rates, you have all age groups until the last one. Some countries might not have so refined information up to 60 plus. So some of these mortality rates can go only up to 80 plus or 85 plus. That depends on data availability. And you see that the first age group here is just 1 year, only from 0 to 1. And here's from 1 to 4. Why we break the first one instead of just being 0 to 4? We break it 0 to 1 and 1 to 4. The first one is related to infant mortality rate, because the chances of babies dying before reaching age 1 is much higher than when they are between 1 and 4. This is true for Nigeria, this is true for Guatemala, this is true for Japan. Based on this data in 2011, it's standard all over the world. So the chances of dying are really high until the baby reaches age 1. And then when the baby reaches age 1, he or she will be much less likely to die. And then you keep decreasing a little bit, but then after some ages, we start to increase. But look for Nigeria. These rates were high. And again, these age-specific mortality rates are also estimated per 1,000. What does it mean? Get the number of babies that died in a specific year, in 2011 in Nigeria, who died before reaching age 1, and divide by all the babies that were born in Nigeria in 2011. And then we multiply by 1,000 because this number here would be too small to interpret in a quick way. So for Nigeria, out of 1,000 babies being born in 2011, 100 died. In Guatemala, around, let's say 40, something like that. In Japan, only around, let's say three or four per thousand. So there is a lot of differential here between countries. But what I'm showing more here is the differential within a specific country by age. So this rate of 100 deaths per 1,000, it's reached again in Nigeria just at the age of 75 to 79. Only 75 years later, the rates of dying reach that high level. Exactly because these countries still have a lot of like issues of communicable disease, infectious diseases that are really high among newborn. But for Guatemala, same thing, this high level here, you're gonna see it again only at 70 to 74, around that age. In Japan, around 50 to 54. Because the level in Japan is so small, then you will reach these higher levels again at younger ages compared to Guatemala and Nigeria in this example. So what's important to know is that mortality rates, they vary through time, they vary between countries, but they also vary by age, okay? So we saw a typical curve of fertility rates, and fertility rates are only as to women. Mortality rates here, we included information both about male and female deaths, okay? And finally, migration varies by sex and age as well. Especially in developing countries, sex is related to distance of migration. Usually long distance migration tended to favor males, so males have higher rates of migration when we are talking about long distances, and short distance migration tend to favor females. And that's related to gender roles in societies. Usually when women migrate, they have a higher chance to have to take their children with them. So it's harder, more risky to move with children in longer distances. So the chances of migrating shorter distances is higher among women. With increases in gender equity, migration of females and males tend to be more similar, because then as fathers start to have the same roles of taking care of the children, so the whole family as a whole tend to migrate together. And migration also varies by age, is age selective. The largest numbers of migrants are found among young adults. And that can be seen in this graph here. So these are age-specific migration rates in the US. This is migration, this is internal migration in the US. Inter-county migration. So migrants in this case here are those people moving from one county to the other between 2011 and 2012. And this information is in percentage. So for people between 1 to 4 years of age, in 2012, back in 2011, 6% of them were living in another county. And here, again, I'm talking about both sex together, men and women. Why it starts from 1? It doesn't go to 0. Because the question here that's being used to estimate these migration rates is based on, you are now being interviewed in 2012. Where did you live exactly 1 year ago? Those children in 2012 that are below the age 1 were not born exactly 1 year ago, exactly 12 months ago. So that's why they're not included here, right? But you see that children have higher rates and then start to decline. And then as people enter into college and then finish college, start looking for jobs, move to another city, move to another place, state, And then as people get married, start to have children, their chances of migrating decreases, right? They get more settled in specific places. And then in older ages, you might see some increases in migration rates. This case here might be people moving to institutions to take care of the elderly. So the rates of migration are higher, in this specific case here for the US in this time, between the ages of 20 and 34. And what's an important thing to notice here is that these children here, these rates usually mirror these rates here, which are the rates of the parents. So these are the parents moving with their children. And this is kind of interesting because some countries, you don't see parents moving with children as much. For example, in China, people moving from rural to urban areas, they have to have the approval of the federal government to move from rural to urban areas. Otherwise, if they still move without the approval, they will not have access to government benefits, health system, and so on in the area of destination. And they will actually have to work in the informal labor market because they don't have the permit. So what usually happens in China is that men leave rural areas with higher chances to urban areas without their family. So the rates of migrating, these rates here of children are usually much lower in China. They don't mirror as much the rates of parents. And looking at these different countries over time, comparing different countries, comparing the same country in different years, that's an interesting thing to do. Because when you start looking at these rates, you start to see these variations. And we're gonna see more examples throughout the semester. So this was an analysis of showing how migration, fertility, and mortality vary by age and sex. Why do they vary? Why mortality, why fertility, mortality, migration vary, and then causes these changes in age and sex composition? And moreover, why age and sex structure are important for us? Age and sex structure are important for us to study because they help understand demographic history of a specific population. I will show you here some age-sex composition of population. There is a nice pyramid for France that the author really estimated the age and sex composition for single ages. And then you can see how the fluctuations, the variations by these age groups is really related to historical aspects that France experienced throughout their history. Historical aspects that France experienced through time. So persons of the same age constitute a group or a cohort who were born during the same period. Therefore, they have been exposed to similar historical facts and conditions. And these experiences also differ according to sex. As we saw with the Lexus diagram, the analysis of cohorts are important to see how people, how different specific cohorts, they experience similar socioeconomic and political environments throughout their lives. And understanding the age-sex structure of a specific population and what they experience over time is an interesting topic for research. Income, home ownership, occupation, or group membership are likely to vary by age and sex as well. Usually older people make more money. And then when they get retired, usually their earnings, they decline. Occupation is usually higher among people in labor ages. So group membership, maybe older people live in specific institutions looking for more social interaction, they have higher rates of group membership, and so on. Age and sex structure of human population sets important limits with respect to sustenance organization. So age and sex composition, age and sex structure it's important for us to know whether a specific society will have enough resources to sustain itself. The demographic structure of age and sex contains the possibilities and sets the limits of organized group life. If you have more children in a specific society, if you have more younger people, you will need more schools. You will need more money invested in schools. If you have more people in older ages, you will need more public policies implemented to take into account a larger proportion of the population in older ages and provide them social security, for example, or even health care for older people. If you have more people in labor ages, you have to create some dynamic of job creation in your country. So these people in labor ages will have jobs to work, so unemployment will not increase, and they can work to provide products for the younger and older population. So knowing whether your population is younger or most of the population is in labor ages or in older ages is important to know how, as a policymaker, you should think about how your society should be organized, right? The degree to which a population's age and sex structure limits the kinds of sustenance activities is an important analytical issue. Someone is asking through a ship, he posts a phone number to add him to the group me, and that I don't know what to do, so you guys can do it. And the degree to which a population's age and sex structure limits survival, sustenance activities, and how that varies through time, it's still an important topic. It's still an important subject to be explored. Nowadays, because of all the changes that we are seeing in climate, all climate change, all these environmental changes that are going on, a lot of studies have been done about how climate change, for example, affects migration, and how climate change might affect the ability of specific populations to have enough production, agricultural production, economic production in their population. So all that, people moving away, less land to produce, all that will affect the capacity of people sustaining themselves, okay? And here I just list some demographers that through time developed some important theories trying to link different demographic patterns and how that varies by age. So Ainsley Cole developed a theory to try to explain the marriage patterns by age. Louise and he, the description of fertility patterns by age and the absence of voluntary fertility control. In this case, without contraception, still fertility patterns, they vary by age. What are the drivers? What's motivating that? Andrew Rogers, he was a professor at the University of Colorado at Boulder, and he retired in the geography department. And he created this mathematical model to exactly try to understand that migration rates by age. So that age-specific migration rates that I showed to you for the US, he created a mathematical model that pretty much estimated the level and the slope of each one of the parts of that curve. And that's really powerful for us to try to understand different patterns across societies, right? And so that's important because if we have a lot of those age-specific mortality rates, age-specific migration rates for several of different countries over time, it might be hard to compare them visually. So these mathematical models provide some indicators, some parameters that make it easier for us to compare them. And the stable population theory is actually the most powerful and elegant form of mathematical theory in demography. It incorporates a population's age and sex structure, particularly age. And with exactly the stable population theory, we can do all these different projections of population. So the United Nations, when they are doing the population projections, they have some assumptions of how fertility is behaving through time, also migration, also mortality. And thinking how the current age structure will be in the future, we usually use this stable population theory to do this, make these projections. What exactly is the stable population theory? The stable population theory, usually we are talking about a specific society, not taking into account immigration or emigration. Whenever we are doing an analysis in demography, and we are saying, okay, I want to see how this population is changing over time, but I will consider only fertility, only mortality. I will not consider migration. I will not consider that people might be moving out or moving in. Whenever I'm doing this analysis, I'm doing an analysis of a closed population. Whenever you see demographers saying, oh, I developed this study and I considered the US a closed population. A closed population, so I'm saying that I'm considering the fertility and mortality rates that are changing over time in this country, but I'm not considering that people might be moving away and moving in. If a specific country like the US has a lot of immigrants, then an analysis that considers closed population is not so reliable because we are not considering a really important component, which is migration. But overall, this is the most important thing about the stable population theory. Let's say, for example, more recent decades in developed countries, fertility has been declining a lot and it has been kind of stable around 2 children on average for a woman. Some countries have more, 2.3. Some countries have less, 1.8, 1.9. Some countries have much more than that or less than that. But let's say that a specific country has fertility rates that decline over time, the total fertility rates, the overall number of children that women have on average. And let's say that they are being stable, around 2 children per woman. And let's also say that mortality rates are not varying so much. Let's say that we are not living in a pandemic, mortality rates are kind of stable over time. And you saw in Japan, the mortality rates much lower than in Guatemala and in Nigeria. Let's say that we are living in a country that mortality rates went such a low level that it's not declining as much anymore. It's kind of stable. So mortality and fertility decline to so low levels that they are not varying as much. So if the fertility and mortality rates are not varying so much over time, if we see constant age-specific fertility and mortality rates, age-specific, by those, like we saw in those graphs, if that population has those age-specific fertility rates and mortality rates kind of stable over time, not changing so much, that society will develop the constant age distribution and grows at a constant rate, irrespective to its initial age distribution. And this is important. Why? Just think about the age distribution of a population, the pyramid, the population pyramid. We are saying that if age-specific fertility rates drop so much and age-specific mortality rates drop so much, still you can have more births than deaths in a specific country. But that country will tend to grow at a constant rate. If a specific country has more deaths than births, so that country will decrease in size at a constant rate, right? So the age distribution will be constant because you pretty much will lose and the same amount of people in all these different age groups. And the fertility being low is pretty much just replacing the older generations of children that get older. So demographers sometimes indicate that the stable populations forget their past because with these constant fertility and mortality rates by age groups, it creates a constant age distribution. So the age distribution of a stable population depends more on the age-specific mortality rates and the rate of growth. The rate of growth is going to be pretty much the overall number of children that are being born, and then what's the age-specific mortality rates? The age-specific mortality rates we saw in these are examples. If these age-specific mortality rates are not varying so much more over time, they're kind of stable in this level, and the overall number of babies being born over time is not changing so much, then you tend to have a constant age distribution. And let's say, I gave you two examples. They are low and stable, fertility and mortality, but I said, if we have more births than deaths, the population will grow in a constant rate. More deaths than births, the population will decrease in size in a constant rate. But if we have exactly the same number of births and deaths in a specific year, then we have a stationary population. A stationary population is it's one type of a stable population. In the stationary population, the number of overall births and deaths are similar. So there is no change in the size of population. And it is also, this kind of exercise is estimated considering this aspect of a closed population. We are not taking into account migration. So with what we're gonna see, the life tables. Life tables is pretty much this spreadsheet, this technique that we will learn, that we can estimate life expectancy at birth. What is life expectancy at birth? Oh, a specific country, on average, people are living up to age of 73. How is that calculated? The life expectancy at birth. The life expectancy at birth is calculated with this. You just have to have the age-specific mortality rates for one country and 1 year. All these rates here from Japan, based on these rates, we can estimate a life expectancy for Japan in 2011. The same thing for Nigeria and Guatemala. So if we have this constant death rates over time, and using the life tables, we can estimate the life expectancy at birth. And also with the same life table, we can think of how the population is going to be in the future if there is no change in fertility and death rates by age, and the number of overall babies being born and people dying in a year is similar. So the life table uses the age-specific mortality rates. It calculates the life expectancy, but it also gives us an idea of how the age structure of that population is going to be in the future if the mortality and fertility rates are not varying so much, and if the number of people being born and dying is similar. So we're going to see that in really clear terms with the life table. So the population pyramid is a more simple, easy topic for everybody here. It is a graphic representation of the age-sex structure of the population. It's also called age-sex pyramid. But due to changes in the shape of population distribution, it has been simply called age-sex structure instead of pyramid. And a population pyramid is nothing more than two ordinary histograms, bar graphs representing male and female populations. And usually we can do it either by 1 year or 5-year age groups, right? So this is, I got this age sex structure for the world for like 1950, when the population was around 2.5 billion people, from this website here, populationpyramid.net. So if you can go to this website and look at historic information, not only about the world, but about specific countries as well. Compare countries in different times. And you see, the left side here, we have men, and the right side, we have women, and we have a 5-year population pyramid. So the first group here, we have 0 to 4 years of age. So 6.8% of this population, of the world population 1950, was of male children between the ages of 0 and 4. Some of these age sex structures, they can add up to 100 all over, or you can do it 100 on the left side and 100 on the right side. Here's 100 adding both sides together. So in the world 6.5% of women between 0 and 4. So more boys being born than girls back in 1950. And when you reach older ages, then you start to see more women, 1.8, 1.7, 1.5, 1.4, and so on. So this, you can see differences between sexes and also across age groups. And as the population gets older, it starts to decline the percentage of the population in those age groups. 2000, you see a decline in fertility. So it dropped here from 6.8 and 6.5% of male children and female children to 5.2 and 4.8. And it starts to get a different shape, not so clear, a pyramid with a large base. But it's still more young boys being born than girls, but in older ages, you see more women in older ages than men because they overall live longer than men. 2020, fertility goes even lower, and since these groups here get old in the next 5 years, get old in the next 5 years, these groups here starts to get a little larger. So you see the group from 30 to 34, it was 3.3%, then 3.9, and then 4%. As the children get older and fertility declines and mortality declines, fertility declines, you start to have fewer children here. Mortality declines, you start having people reaching older ages, more people in percentage terms reaching older ages. The projection to 2050, also then you start to see even a more rectangular shape of the population, but still in older ages here, a lot of developing countries, not many people reaching those older ages, so you still see this variation after the age of 64, for example. And then projections also for 2100, and you expect even more of a rectangular shape. And this is the age sex structure that I mentioned that I think it's interesting for France. In this case here, you see that these bars, the horizontal bars here, they are much more refined. That's because they are for 1 year, for each single year, instead of being 5-year age groups. And here they relate some historical events that happened in France to how the age sex distribution of the population is. So this is data for France in 2006. And this, you see here, these cohorts here are smaller, both for men and women. And this is the birth deficit due to World War I. So you had the decline in fertility exactly because of World War I going on in Europe. Here, also, you see this gap, this fewer people in those ages here on this number 2, and also for women here, depleted cohorts when they reach reproductive age. So these people here, during war, you had a decline in fertility, exactly because of World War I. So when these people here, they were in reproductive ages, although fertility went back to the normal level, around 2 children per woman, overall, they were a smaller group. So these people here are the children of these people here. These ones are the children of these ones here, right? Or overall, these women and these men are the children of these two groups here. So that's history, World War I, telling us what's going on in more recent years. And this is the year of birth of these different age groups here. So they added more information, the year of birth. And the horizontal axis here, they did not put in percentage. You can also put it in absolute numbers, so population in thousands. 3, the birth deficit due to World War II. So here you see this deficit here compared to here. It's exactly fewer people having children because of World War II. And after World War II, you start to have a baby boom. So economy is growing, more job opportunities, people have more desire to build a family, and then you start to have higher fertility, and then you start to see higher, bigger cohorts in France, in those being born between 1945 until around 1975. And 1975 is the end of the baby boom, like in the mid-70s. So it goes from 45 to around 75. Cool. So if you have refined data by single ages, you can construct age structure for a specific population and tell the story based on a simple graph like this. And this is data from India in 2010 and the projections for 2050. 2010, still high fertility in India. And as this country also starts to have fewer fertility rates start to decline, then you start to have fewer children in comparison to people in older ages, because these ones here are getting older. So 40 years later, from 2010 to 2050, they will jump up and there will be more people here. And these people are not having as many children. So here you have fewer children. In China, because of the one-child policy, and also some authors mentioned that all the economic development that China had, urbanization, it's more expensive to have children and so on, you will start to have this huge decline in fertility. So declines a lot compared to people in reproductive ages here. And these people in reproductive ages in 2010, they will get older, they will reach their 60s. And that will impose a lot of pressure on Social Security in China. And now, even if these people here start to have more children, because now the one-child policy was relaxed for people to have 2 children on average, they cannot go up to these levels because they are already a smaller cohort, right? And just remember that even with the one-child policy in China, it actually, on average, women, they had 2 children during those decades, from the late 70s until the early 2000s, 2010. So from 79 until 2015, when the one-child policy happened. In the European Union, fertility declined much faster, much earlier in those European countries. So that's why you see much lower numbers of children, both women and men in younger ages. And these people here are getting older. And again, we put a pressure on Social Security. United States, the decline in fertility is not so pronounced as European Union. because usually immigrants here have more children than the US born population, and kind of like creates this more stable population age structure, which is good for the country in terms of planning for the future and have economic development. So it doesn't create these issues of providing Social Security as much as in European Union countries when they have so much decline in fertility. So the fertility of these specific groups, usually immigrant groups, Hispanic population, helps the whole population. And this is just to show you this Llano County in Texas in 2013, to show that's a county. If we start to break down for specific states, specific counties, you start to see much more variation. So this is a county with like a really old age sex structure. So higher, much higher percentage of people between the ages of 55 to 64, both for men and women. And then when we see Brazos County, exactly because Texas A&M being so big, then you see these huge numbers, and this is in percentage terms, of people between 15 and 24 years of age, and exactly because of college age between the ages of 20 and 24. And not as much, in percentage terms, older people, right? I just want to show you in the horse website, under the lecture 2, there is, you can already download these slides that I just showed you. And there is this nice video organized by the Population Reference Bureau, which is an agency based in DC. And I also put this compressed file, zip file, examples of age, sex, structure, and other indicators. If you download this, this is a zipped file. And if you uncompress it, you're gonna get this Excel age, sex, structure, and then you have some examples of bar charts, histogram, line chart, and pie column charts. The bar chart is actually the age sex structure. It's just to show you how you yourself can do your own pyramid. So if you have information about a specific area, a specific county, a specific country, or whatever, you can have, if you get the information of the male population, a specific year, broken down by age group, and also for the female population, you have to pretty much transform these absolute numbers into percentage. In order to work, you have to put one negative and the other one positive, and then they show up here. So that's 1970 Brazil, 1980, population getting older, fertility declining, mortality declining, in 2000. And if you go to the slides here, this populationpyramid.net, here, that's where I said, like, you can choose a specific country, and let's see, let's get here Mexico, and then you can go, you can see the percentage of men and women in that specific year. You can download that information to Excel. And I pretty much just print screen this to make the PowerPoint presentations. And if you pass through the mouse here, you'll see the absolute number of people in those years. And here, where is that? I can change, I can move, if I click here on +5, it changes, let's just do 2040, 2045, 2050, 2055, and so on. And I can do this for a series of different countries. If I want to do for a different county, state, I have to get information for that specific area and do it by myself in the Excel spreadsheet. But if I want to see variation over time for a specific country, you can see here. And this is the projected population in Mexico, so, projected to get at higher levels in 2060 and then dropping after that. Right? And you can just select whatever country you want here on the list. And so that's it. And I will continue on this chapter going to age dependency on Thursday. Thank you very much. I see you guys on Thursday. The quiz number 2 is open. And remember, 2 multiple choice questions. You have 5 minutes to answer. And it can go back to the first chapter that we saw, okay? Thank you very much and have a great rest of the day.